Hello, welcome back. So I've got a problem here, and if you know the trick, it's pretty quick. But what happens if you don't know how to do a problem? And in fact, that's a lot of problems you'll come across. You'll come across problems that you'll see and you just won't have a clue. If you've seen a problem before, chances are you'll have an idea how to do a problem and you'll be able to get it. So what happens if you don't know? Well, you got to do something. You may have to spend some time with the problem to understand it. And I'm going to take this opportunity to give you an idea of the problem solving process. So let's look at this problem. 7 dashing knights are in love with the kingdom's princess. Starting on January 1st, 2021, the first knight visits the princess every day. The second knight visits the princess on January 2nd and every second day thereafter. The third knight visits the princess on January 3rd and every third day thereafter. The pattern continues for each of the 7 knights. What is the first day on which all 7 knights visit the princess? So, reading through it is not a bad idea. Sometimes you may have to stop after every sentence and try to understand what the heck that means. I think it helps to write down this information in your own words. Usually when I'm solving a problem I don't know what to do with, I'll write down what I know and what I want to know. And then you got to try to figure out a way to get from what you know to what you want to know. Usually what you want to know is often the last question of the problem, and that may involve assigning a variable, and maybe you'll make an equation that will get from what you know to what you want to know. In this case, we're just going to write down what we know and what we don't know. So first, let's just write down everything that we know from this problem. Basically, I just wrote it kind of in my own words. Knight 1 visits on January 1, 2, 3, 4, 5. Knight 2 visits January 2, 4, 6, 8, 10, 12, etc. And finally, Knight 7 visits January 7, 14, 21, 28, every 7th day. And already writing this out, you might start seeing some patterns. What I want to know is when will all 7 knights visit on the same day? I'm just kind of reiterating the question. So one thing you'll notice with these nights, at some point we're going to get past January, we're going to get into February, and then it'll be really hard to keep track of what day we're on. So what I'm going to probably do is just start counting days. Day 1, day 2, day 3, day 4. That will be easier, and then later I can convert it back to months and years to get the actual date once I have my answer. And that's what I wrote here. And sometimes you may need to draw a picture just to understand something. At least you're doing something. The hope is that it will click. You don't have to draw a picture. You could make a table or just write out the numbers, and hopefully you'll see a pattern. Now, another good thing to do is just start simple. Don't try to do all 7 knights right now. Start with like the first 3, knight 1, 2, and 3. See what you can notice just from that. Drawing a picture might help see when things line up. Here's a grid for knight 1. I'll label the days 1, 2, 3, 4, 5, 6, etc. Notice I'm not worried about what month it is. I'm just labeling days. And it's labeled K1 on the left to refer to knight 1. Now I filled in the boxes every single day for when the knight 1 visits. So let's look at knight 2. Here's the grid for knight 2, and those are the days that knight 2 visits. So just with this, knight 1 and knight 2, you can see when do both these knights awkwardly visit on the same day. It looks like day 2, day 4, day 6, day 8, 2, 4, 6, 8. Those are multiples of 2. Let's add another knight, and maybe we can see a little bit more of a pattern here. There's knight 3's grid, and knight 3 visits every third day. 3, 6, 9, 12, 15, 18. Looks like they line up at 6, 12. Where they line up represents when all 3 knights are visiting on the same day. So you can see we're kind of starting to just try to understand the problem just with a smaller set of knights. Don't try to do the whole problem, do a simpler problem. So anyway, we're going 6, 12, 18, 24. These are the multiples of 6. Now how does that relate to knight 1, knight 2, and knight 3's frequency? Knight 1 visits every day. Obviously, knight 1 will always line up with other knights, so you kind of can almost ignore that one. Knight 2 visits every second day, 2, 4, 6, 8. Knight 3 visits every third day, 3, 6, 9, 12. Well, 2 times 3 is 6. And all multiples of 6, they line up. So So it's just stuff we're noticing. We're not getting too attached on, gosh, we got to find that answer. Just pay attention to what the pattern is. Okay, so let's add the rest. There's night 4, every 4th. Okay, when do they line up now? Looks like at 12, and then at 24, multiples of 12. Well, 2 times 3 is 6. 6 times 4 is 24, though, right? And 24 is here. But there is an earlier time when they meet. A smaller number that is a multiple of 2, 3, and 4. Starting to see a pattern? So let's look at night 5. Things get really interesting with night 5 and 6. However, with the grid that I've made, you can see that we need more boxes. So we need to start maybe thinking about converting this grid into just numbers. So let's add night 6 and 7 just for fun. So there's night 6 and 7. And you can see how they're not meeting up nicely. Not within 42 days. They must all meet up well past this. Even at night 5, they don't meet up for a bit. So you might need to write out. Instead of write it as a grid, write the numbers. And for each, like for the first 3 nights, figure out what that common multiple is. I'm using some words here. It's not a bad idea to keep in mind what you're studying at the moment when you're doing a certain problem. If you're taking a class, what section are you in? And what chapter are you in? Chances are, it probably has something to do with something you're studying. Hope this is enough of a hint for now. We'll talk more about this in the future. See you next time.